In the interest of time, I would like to start this session. First of all, again, thank you all for joining today. And before we actually introduce you to the topic, we would like to introduce the Canada Community of Practice. I'm also the organizer for the DevOps Summit, which happens in Canada. It's this time it's happening November 8th and 9th. So I welcome you all there. And without wasting any time, I would like to introduce Massimo, who is leading this wonderful team of CBC. And we are going to talk about DevOps and how, they have embraced the rise of open source software in DevOps and what are the kind of opportunities and challenges they see from their side. And they will like to share with us their journey. So Massimo, thank you very much for actually taking out time and coming to the community of practice and sharing your knowledge. So over to you, Massimo.
Thank you, Garima. Thank you for the introduction. Thank you, everyone, for joining today. And thank you for the people that know us. And Dave, amazing Pac-Man in background. Love it. And thank you, everyone, of course. So let me introduce myself. Massimo Mollica, and I'm the manager for the WebOps and infrastructure team. Today, we're going to focus on the DevOps side of the work we do. I love to talk about my team as the catalyst around containers and open source adoption. We're going to focus a lot on these two topics today, and we're going to explain how we help digital team to adopt open source without the fear of open source. And we'll get more into that later. Now, allow me to talk more about CBC Radio Canada. CBC Radio Canada, as you know, is national public broadcaster, and is the largest in Canada. Of course, I think we're number one, and the corporation is leader in reaching Canadians on all platforms, new and old. And I would like to underline old. We support everything. We have radio, television, internet, satellite web-based services in very remote locations. We have podcasting, we have different type of video online. We have gem.ca, we have Tudo.tv for OTT platforms as well. And people are loving them. We see a lot of people subscribing. CBC is deeply rooted in the regions, and this is quite important as well. Not to mention that we have 17 plus foreign bureaus. So we are all around the world. We can give you news and deliver news all around the world. Something that I'm personally proud, and I honestly think that we are the only domestic broadcaster, and it's my opinion, but I think we're the only domestic broadcaster to offer diverse regional and cultural perspective in English, French, and 8 Aboriginal languages. And that makes me particularly proud because we're reaching out and being very inclusive. Another thing I would like to share with you is that CBC gave herself a very important goal, reaching 20 million Canadians by year 2020. So basically 20 million Canadians every month looking at the website and consuming content. Well, we not only reached the goal, but we reached the goal almost 2 years ahead of time. By late 2018, we were able already to have 20 million people on our platform. And now we are well into 2021 and these numbers keep on growing. There's a lot of work and effort that goes into it. There's a lot of people working behind the scene. And I would like to say thank you to all those people that put a lot of effort in presenting the content to you, making it always competing against everybody else in this industry, and always find a way to keep you entertained. Now, let me move on and let me introduce you to how we're going to do this today. We're going to do it like a panel. So I've never done it before. I've never done a panel on a webcast Zoom call. So let's try. I'm going to have a very nice flow of questions. I'm going to talk with Carrie, with Natalie, and Cassis. And I would like to start with Natalie today. My first question will be to her. Natalie, she is my supervisor. She, I think, followed the most canonic path, if you will. So she came as a developer, she became a DevOps, and now she's leading the team into the next foreseeable future and helping them to achieve the new goals. So Natalie, how important is open source for DevOps in our environment?
Thank you, Massimo. Hello, everybody. Thank you for joining us. And indeed, I've just a quick word about myself. I've been at the CBC for just over 13 years now. And I always like to say that I went from dev to ops and never looked back. And it summarizes my career, my career path quite simply right now. Indeed, I started as a developer, and I was lucky enough to start as a developer. That's over 25 years ago, which doesn't make me feel any younger. I started at the time when open source was not in its infancy, because open source has existed for longer than I've been alive, but that open source allowed us to grow into better developers and into better sysadmins, because it made a lot of tools and a lot of content available to us. So it helped us learn and build our core knowledge on platforms that then, because there were so many of us knowing them, were more easily adopted by the industry. Well, that's a little bit too broad. More precisely, at the CBC, we've always been very strongly open source driven. Started as a pretty standard LAMP platform of Linux, Apache, MySQL, PHP. And the primary motivator for that, like many other organizations, was simply that having a Linux platform with these tools was free. It wasn't necessarily always about participating in writing the code, it was about using it. And that's two important aspects of open source too. It's the free is in free beer. So from then on, and it's no secret that in the last 13 years, the industry has grown through a massive shift and a massive change. And it would not have been possible without open source. The way we evolved through it was very much in parallel with what was happening, all the while keeping in check the fact that we had a platform that had to grow without massive interruption, but we still had to carry on with following what was happening in the industry. So the funny thing that we saw happen was that that's the way open source drove sometimes or adoption of sometimes more commercial platform. We were using, when I joined, we were still using CVS. Then we moved to SVN. At the time, we needed to track our bugs, so we were using Bugzilla. Bugzilla, if you've used it, not always the most user-friendly aspects of development, but the notion that bug tracking and documentation was important was implanted. Came the Agile revolution, and we start needing to have a different platform to integrate the way we manage the project, where we manage the bugs. And that is where a platform like Bugzilla, which was an open source platform used and popular, drove us to more commercial alternatives that then grew because the need was created, and we moved to commercial offerings for issue tracking and project mapping. Similarly, one of the first CI/CD component that we built was an experiment for mobile builds using Jenkins from someone's desk. CI/CD revolution grew, and we had more and more developers needing to adopt these new technologies. And we went from Jenkins to another commercial proposition, mainly because they offered support. And that's also a big factor in the development of open source, is that sometimes you can stay with open source because it is still free, but you still want to have that added support. So in our Linux evolution, for instance, we went from different flavors of Linux, and we are now a Red Hat shop, because Red Hat still supports an open source operating system, but with additional support. So that's where the free become a little bit less of a factor. But back to our developers, because development evolved quite massively, and we use a broad range of languages, and it became obvious that the drive to the tools, to use the tools that were increasingly important to developers, the new versions of Node, new versions of Python, was not always compatible with a very a very fixed platform, an operating system. So our Red Hat platform, for instance, only supported Python 2, and developers needed to use Python 3. There was no support for Node.js at the time, or no real support for Node.js. So, and the need for Node platform was very present. So that, of course, led us to the natural next evolution, which was containers, which we built entirely from scratch, and was the next adventure in open source adoption. Using, we settled, and Cassius will talk about that, we settled on the Red Hat offering because it was still open source and available to us in our ecosystem, which I think summarizes it's a very quick overview, and I'm sorry if I offended someone by forgetting their area, but that's how open source evolved at the CBC for us.
That's good. Thank you, Natalie. Cassius, would like to go to you next. Can you share with us the path to containers adoption specifically, and the challenge you have faced and face today?
Yeah, sure. Thanks, Massimo. So about 5 or so years ago, we had the goal of more easily supporting microservices. At the time, we had a new application that was being written, the front face of CBC.ca, in fact. And that seemed like a good chance for us to start looking at the containerization of things, because oftentimes when people think microservices, they also think containers. They don't have to go hand in hand, but they do mesh very well. So obviously there's plenty of freely available Docker images out there, Docker files, and we can either use those directly or as simple reference points when we build our containers. Kubernetes, and if you're not familiar with Kubernetes, that's an open source container orchestration platform. At that time, it was relatively new, and there weren't really many organizations that were using it in production environments, at least not at the enterprise level. So as Natalie mentioned, we sometimes will look for support on top of open source applications. And so we chose to go with Red Hat's Openshift, which is a Kubernetes variant. It's still open source and it is Kubernetes, but it offers a lot of additional things like build tools that are really helpful for the development cycle, as well as the ability to more easily deploy things. It includes a router, for example, so we can more quickly expose applications as needed. The other thing with containers is that they deliver very consistent results, both on the build and on the delivery of them as well. They allow for easier item potency for a more consistent result. So Openshift has a built-in container catalog as well. So somewhere to the tune of 50 or more different platforms are already built into it, or frameworks rather, are already built into the platform, so that developers can kind of pick and choose which languages that they want to use quickly. On top of that, we also use Nexus to support the build dependencies. But once you've built your application in artifact into a container, it already includes all the dependencies that it requires in order to become a functional application. So you can take it from one location to another, one environment to another, and sort of shift it around, and it should function the exact same regardless of where it is. The other thing is that it meant that there was less infrastructure delivery time. Obviously, waiting for infrastructure to come up so that you can start working on your application can be slow sometimes. Containers, they're there. There's, like I mentioned, there's more than 50 of them on Openshift, and a developer can get up and running really quick in minutes, as a matter of fact. They're also able to make system level changes if they choose to within containers, as opposed to just to their application code. So that can be useful for them as they experiment. So essentially on their local machines, because they're building their code in the container, they're more or less working in a production-like environment, since it's that same container that will ultimately end up in production. But the adoption of containerization came with some significant challenges as well. In fact, they changed almost everything about the way that we operate, both from a technical and a non-technical perspective. But from the technical side, for developers, for example, they had to make decisions fairly early into the development phase, if not in the planning phase, about things that they would need to consider. One example of that might be high availability, for example. It's very rare that you run a single container. Especially on Kubernetes, you generally will run multiple copies, so a developer has to think about things like that as they're going through their development cycle. It also meant that developers needed to have a bit of a better understanding of the system and the overall architecture that their application would be deployed to. And lastly, for developers, it meant a dramatic shift in the way that they build their code. You know, they were used to one way of doing things, and then by throwing containers into it, it meant that they had to sort of shift the way that they were doing that. But from the operations side technically, we required a better understanding of the overall dev process that developers were going through, as well as a better understanding of the actual applications they were developing and the build tools that they were using. We had to completely remap a lot of our CI/CD pipelines. I think we have somewhere in the neighborhood of 30 to 50 applications that we've migrated over into containerized environments. And also from the operations side, system level changes require container rebuilds. So those changes go through the entire pipeline. And an example of that might be, usually we'll hop onto a server, say we want to update curl or something like that. We'll hop onto the server, we'll update it, everything is great. But when it comes to containers, you go in there, you install curl. Well, it's ephemeral. So when that container gets restarted, that change is gone. So the operations side also needs to implement things in code now as well. And that goes through the pipeline, ends up in the container, gets deployed, and so those changes will continue to exist. The other thing is it required a change in the way that we collaborated. So operations is no longer solely responsible for the environment contents. Both operations and developers had to work together to produce the application and the system dependencies. That meant that there needed to be a bit of a knowledge transfer between both sides. They sort of had to understand where each other was coming from, and resulted in a better understanding of each other's challenges. So obviously that brings empathy from one side to the other as well, which is a good thing. So just to sort of summarize here, the containerization efforts that we went to presented us with some pretty significant challenges, I'd say. But most importantly, it required a shift in the way that we sort of think about things and the way that we collaborate.
That's good. Thank you, Cassius. Natalie, can you share with us one of the challenges you had to overcome during the adoption of open source?
Yes, Massimo, I think we had many challenges. I have a good example for you that illustrates a combination of the human factor that Cassius has mentioned, as well as the challenges, generally speaking, around adoption of open source nowadays, in that we're not facing a massive ecosystem of open source content. There's a little bit too much to choose from, and there's not always the corresponding expertise with it. Partially, frankly, because every week we seem to have a new revolutionary open source project. There are many challenges that we are facing with open source adoption, and Cassius mentioned the human challenge, of course, that is always very important. The main one we were facing right now is that there's quite a lot. There hasn't been a week without a new open source project that is going to revolutionize the way we deploy an infrastructure, manage our containers, secure them. And in a way, we are now in this position of an embarrassment of riches of all of these products, with very little long-term expertise, because it's quite impossible to build long-term expertise on a product that exists for only a year. That we are all very excited to adopt, because very often the promise is very appealing. And how do we then regroup and go back to the notion that we should always keep the need first and not the technology? No matter how exciting the technology is, we should always go back to questioning what is our need for what we want to achieve right now with our platform or with our applications, and then select what is the technology that will serve that need best. And then we still have challenges. So the case in point that we went through was, as Cassius mentioned, we moved to an Openshift platform, which is excellent in itself. And a couple of years ago, we also decided that we were going to increase our cloud presence. We already had some elements of our application, in Google Cloud. We also had some other users at the CBC using Azure. We had a presence in AWS, and we wanted to rebuild our Openshift cluster entirely in AWS. And from the beginning, we decided to make a very strong commitment, since we could start from the beginning, because part of the problem sometimes is retrofitting the new concepts into older elements of our platform. But since we could start from the beginning, we decided to go with a very strict infrastructure as code framework, making sure that everything that we were going to build in the cloud from now on was going to be implemented as IAC. And then becomes the challenge as to, okay, do we go with the AWS CDK? Do we then learn Azure's way of managing, because all of these clouds, of course, allow you to manage their configuration as code. That's not the challenge. The challenge is we now have 3 major clouds that we want to work in, and 3 different languages, 3 slightly different ways of working. So with all of that, that was the need. The solution to us came in the shape of Terraform. And Terraform resolved a lot of these needs in that it allowed us to learn only one language, one structure, one syntax, and then only adapt it to the different types of cloud that we wanted to deploy to, with the added bonus that it could also work for our VMware infrastructure that we're still supporting. So we embarked on it, we learned, we spent a lot of time building an Openshift cluster in AWS, and that is not a small, that's not a small set of configuration. It's a lot of nodes, it's a lot of, thankfully it's one VPC, but it's a lot of EC2 elements, it's some security groups, it's all the configuration for all of the access and security, all of that in a long series of carefully crafted Terraform plans, which were built with Terraform 0.11. So if you have worked in DevOps and in Terraform and infrastructure as code for a little bit, you know that between Terraform 0.11 and Terraform 0.12, there was a massive change in the language. Not an impossible change, but a really big one. And that is one of the typical issues that we have with open source right now, is that a minor point release can mean a lot of change. And these changes are part of the nature of DevOps and open source right now, is that things change fast and you need to be able to adapt very quickly to that. So when you have just a couple of instances, it's somewhat easy. When you have a lot of infrastructure, it's a lot of investment that you need to put in to manage all of these quick changes.
Absolutely, absolutely. And that's how open source can help people like us and corporations to deploy massive infrastructures. So thank you for sharing that. Kerry, let's switch gears a little bit. In your SecOps role, what can you share that will help to understand how new methodologies are used and adopted?
Kerry, you might be on mute.
Yeah, probably is on mute. And Trent, I think you're trying to figure
it out. Sorry about that. I was unable to unmute myself. I guess it was a policy that was added after that previous debacle. Okay, so thanks. Our objective in SecOps is to secure systems, applications, and data. That's done by integrating tools, automations, and policies. Another more difficult objective is to achieve this without negatively impacting the time it takes for software to reach production or to provision new resources. As far as the newer methodologies that are used by SecOps, those are in large part thanks to DevOps and open source tooling. Specifically when it comes to CI/CD and infrastructure as code by defining security policies as code. If you're already familiar with DevOps, you'll notice some shared interest with SecOps. First, we have security as code. It's the exact same as infrastructure as code. The same tools are used, Terraform, Ansible, to provision the resources. The main difference is that security policies would be defined in the infrastructure as code projects to increase a secure by default mantra. Building security into the CI/CD pipeline. While we're not there yet, I see us taking a shift left approach. Shift left refers to moving security sooner into the development process, for example, by employing vulnerability scanners during builds. For us at the CBC, it also includes security testing policies for the development and QA process. Work between these departments and myself have started, but we're still in the defining stage of how it will all work. Automation is another similarity. Outside of provisioning resources, automating repetitive tasks is something that has been adopted from DevOps by SecOps practitioners. While the tasks and tools may be different, the inspiration and goal to automate them is the same. Lastly, I feel like culture is largely self-explanatory for those already familiar with DevOps, which is why I put it last, although it should probably be first. And as Cassius had mentioned earlier, constructive collaboration with other teams, be it operations, developers, InfoSec, is essential for the success of both DevOps and SecOps.
Yeah, that's good. Culture is always important, right? Maybe one of the most obvious, but definitely the one that's more difficult to implement and change. And Kerry, what are the security tools you use with CI/CD pipelines?
Yes, so the developers are currently using SonarQube to do static analysis on their source code. However, they're using it more for code quality and to reduce technical debt, not necessarily for security. There are some, well, thankfully SonarQube does do a code level security scanning using a SAST or static application security testing module. That is something that we'll be looking into with the developers and enabling. We also have a Nexus Repository, which became a necessity for us back in 2016 because of LeftPad. For those not familiar with LeftPad, the background would be that LeftPad was an 11-line JavaScript library that simply shifted strings to pad them to the left. Not really a big thing. The developer ended up getting into a naming dispute with the company Kik over having a trademark on one of his libraries that was also named Kik. NPM had ended up siding with the company, and the developer decided that he would retaliate by deleting all of his projects from NPM. LeftPad was one of those projects, and unfortunately it turned out that LeftPad was used as a dependency for many other node modules. Even if your project didn't use LeftPad explicitly, it was likely that one of the modules you used did. This led to hundreds of thousands of Node.js applications being unable to be built one morning. At the time, we only had one Node.js application, and considering our luck, it was one of the ones that was affected and unable to build. So immediately after that situation, we started to use Nexus to act as a proxy cache to fetch NPM libraries from the internet and store them locally. That way, if another NPM library was to be deleted, it would still be able to build our software using the stored version that we had in Nexus. Conveniently, as I recently learned, Nexus can also do vulnerability scans on code in its repositories. An evaluation of this is something in my near future. And of course, we're also open to looking at other tools, but I think we should use the ones that we already have before we start evaluating new things. Enabling SonarQube to do vulnerability scans during the build step and Nexus for the libraries is good as a first step anyway. Doing white, black, and gray box testing on the running applications after deployment is something else I would like to add through automation. I'm going to end this with an honorable mention of some other open source scanning tools that we've used, although they're not specifically related to code scanning or CI/CD. Those tools would be Nikto, Metasploit Framework, Nmap, OWASP Zap, Wireshark, WP Scan, and Skipfish. Thanks.
Yeah, thank you, Kerry. And I still remember the morning. The left badge library was deleted by the user, right? And it was quite a day, right? And the entire world woke up to a surprise. And the GitLab people were involved with store content. It was insane. It was insane. So definitely lesson learned for everyone. Definitely one of those. I'm glad that you'll be in my memory, thinking maybe it's not gonna happen again forever. Looking forward for the next one for sure. Cassius, talk about CI/CD, right? So is this to automate, generally speaking, and build and deliver software to CBC specifically for us, CBC cloud on-prem and on public clouds. Do you mind to tell us a bit more on how we do this, how we deploy in a hybrid configuration?
Yeah, of course. So just a little bit of background. Yeah, we use CI/CD to automate that. In fact, we automate a lot of different things. Of course, you know, when a commit is made, it automatically kicks off a build, and we use a combination of both open source and closed source to achieve our entire pipeline. On the closed source side, Atlassian Bamboo, it triggers the builds which actually occur within the Openshift platform. That's our containerized Kubernetes platform. Bamboo also triggers other build-related tasks within Jenkins. Although with Jenkins, we're generally using it for test suites and things like that. We also have patched together a series of custom scripts, things that we've either written from scratch or that we found online through sources that are available. But Openshift itself, it provides open source build tools, and one of those tools, S2I or source to image, it actually provides two things. One of those things is builder images, builder container images. They're open source and they are freely available. The S2I tool itself, it basically will run through a series of container instructions and build code based on the framework that the container image is using. So for an example of that, if a developer is building, say, a Node.js app, and they use the S2I, the container is smart enough to know, well, this is a Node.js app. I see a package.json, so I'm probably going to want to run an npm install on this. And so those sorts of things happen automatically when using S2I. S2I isn't only for Openshift, by the way. I think it's available on GitHub, but the two do work very much hand in hand. And if you didn't know, Red Hat, they're actually the biggest contributor of source code to the Kubernetes project at this point. So a lot of what you find in Kubernetes these days actually originated within the Openshift platform and through Red Hat and Red Hat's open, or freely available version of Openshift, known as currently as OKD. We also use some custom Docker images, of course, as well. So yeah, the container gets shipped from environment to environment, as I mentioned earlier. Traditionally, one of those things that you tend to hear is it works on my machine, and you've probably all seen that image that I have up there. But it's true, it does happen. I've heard it many, many times while working with developers. But when it comes down to it, really, production is the only thing that matters. And I realize that's very simplified, but if a developer is producing code that works on their machine but isn't going to work in production and will break things, well, you can't promote that to production. So that's time and effort that's wasted. The code that the developer builds on their local machine within a container, on the other hand, can easily be transported around. So you don't have that issue of so much of it not working on production when it works on their machines. To your point, Massimo, about the hybrid, on-prem and multi-cloud, yes, we do that. Natalie mentioned that Openshift our production environment is located on AWS, but we also use Google for failover, primarily through GKE. That combination, even though they're both Kubernetes, it did present us with some challenges because Openshift offers all these amazing build tools and deployment tools on top of Kubernetes that you really want to take advantage of if you're using that platform. However, the Kubernetes object definitions, the JSON files, versus the ones that are sometimes in Openshift, they don't necessarily match one-to-one. So we had to go through and write some scripts to sort of get that to all work together, where we could deploy to both Openshift and have it function, and then GKE or native Kubernetes and have it function there. Lastly, from the CI/CD, it doesn't just apply to the developer's code. Operations at CBC also use the CI/CD for our stuff. So an example of that would be Varnish, our caching layer. When we make changes to that, we don't make them directly on the servers. We do that in code, and then that goes through our pipelines and gets deployed to our caching layers. Also driven from our pipelines are Ansible scripts for provisioning resources, VMs, or whatever would be required. And I'm currently experimenting a little bit with Terraform in pipelines in our CI/CD, where when an application is being produced, it will go out and deploy the infrastructure and then run Ansible on that to provision it, and then ultimately deliver the application code to it as well. So open source tools, such as Openshift, Kubernetes, the source to image tool that I mentioned, and even the Docker files themselves have really enabled us to automate many aspects of our applications and our infrastructure.
Okay, well, thank you. Natalie, we'll go to you now. How open source changed the way you build your environment?
Well, yes, I think Cassius has made a very good segue into that. I think on open source and DevOps principles, maybe infrastructure may be the element that has changed the most recently in terms of DevOps and use of open source tools. It used to be that we had to, for new infrastructure, you had to order a pizza box hardware or a set of blades. You used to have to book the appointment to make sure that it could be fitted in the data center, find the rack, have a meeting with networking to make sure that the proper cable could be installed and installed to the correct VLAN. That's where we used to be. Then we moved into VMware, which at least relieved us from a lot of the complications of hardware installation, but it was still fairly manual for a lot of the steps that we did. And now, and it is not just us, it is generally speaking for infrastructure, we are in a position that we can indeed, that Cassius started mentioning the tools, we started with Ansible. So we deployed our machines on VMware, we created a VM, but then all the provisioning was done through Ansible. All of the configuration was deliberately kept in code, and it took a little bit because as sysadmins, this was not necessarily a natural element. It took learning that, and then the power of it becomes evident, because you have created one VM, you provision it with this configuration. Gone are the days of saying, oh, I need to change this. I'm going to SSH into the console, drop in as root, do some change that no one ever hears about, go back for the weekend, and then we don't know what happened. Now the change are, you put the change into the Ansible playbook, it goes through a CI/CD component, it gets, actually, we haven't put it into all of them, but because Cassius mentions Varnish, I have to mention that we did apply the proper DevOps principle in, for instance, a Varnish configuration. It gets checked into Ansible, it gets checked into code, it gets tested, it runs through a series of validation of just the syntax and does the configuration make sense? And it has saved me personally many deployments that would have been faulty because of a simple semicolon that is forgotten. So this has helped us evolve our infrastructure and the stability of our platform massively in terms of the way we manage it, and also the speed at which we could manage it. Infrastructure as code also means that if something is wrong after a deployment, we can roll back, and we can roll back to a known good state. The final step was, as we said earlier, was to apply all of these good principles to deploying our infrastructure in cloud, which we decided from the get-go that it was going to be code managed and that we were going to use Terraform for that. And this allowed us to now have all of the new systems that we deploy, be them in Azure, AWS, Google, VMware, they all have a corresponding code attached to it. All the configuration is also maintained in code, and all of this can be tracked. Final icing on the cake is that because the Ansible and the Terraform syntax are fairly easy to read, it also provides a fairly easy way of providing documentation and for people to understand what is going on in the deployment of the different systems. So yes, I would definitely say that DevOps and open source has radically changed the way we deploy and manage infrastructure.
Yeah, no, definitely. Things have changed a lot, right? In the past 5 years, there's a lot of new code being written, open source tools everybody is using and is evolving as we speak. And then that's what we described, right? Making ourselves be able to use agnostic tools to deploy in anything that is available today, but changing just freelancer codes and different target. Definitely exciting, right? Infrastructure as a code is one of those one of those must-have. Be able to do it is still a challenge, right? We're still working on it. But thank you, Natalie. Looking forward to seeing improvements for sure, and looking forward to the next step. Kerry, want to go back to you. How do you assess the identity of potential security threats during your daily work? It's okay. Waiting for him to unmute. I guess it's still technical difficulties around that. Maybe Garima, if you can help.
There we go. Sorry about that. Okay, sorry. This is for identifying threats?
Yep.
Okay. So there's a variety of ways that we can identify potential security threats. There's always going to be things that we know, either past misconfigurations, things that we've looked back on that could have been done better, new security features being added into software, things that we've recently learned that maybe changes configurations that we would have done in the past. There's always going to be things that we know that can improve security, and those would be identifiable threats. CBC's corporate InfoSec team has a security information and event management tool, or a SIM. SIM aggregates logs across many of our applications and servers. Those logs get analyzed in real time, and if any incident has occurred, an event is thrown. While the SIM does aggregate our web application firewall logs, I find it useful to manually monitor them as well, largely because that gives me an insight into how people are trying to exploit our services, even though they're unsuccessful. Incidents and requests will come to us from time to time from InfoSec when they need help or assistance with investigating web security related issues that they've been made aware of. Also, actively hunting for threats is a great way to identify them. There's a lot of excellent open source tools out there to do vulnerability scanning on live applications, or any sort of analysis for bug hunting. Regardless of how the threat is identified, it's always good to do a threat assessment to verify the validity and the severity of the risk, and if it's valid, how best to remediate it. The process for an assessment can also vary depending on the type of attack, but there's common questions that should be asked of any incident. What could happen? How severe are the consequences? What are the possible causes what possible causes have been identified? What's the root cause? And finally, what steps are required to prevent it from happening? Assessing and validating threats after they've been identified is essential to reduce chasing red herrings. Another advantage is that it's not uncommon for an assessment or validating an assessment to introduce new incidents that, identify new incidents. An interesting topic that I've recently taken a liking to is threat intelligence. Threat intelligence uses machine learning to help determine risk based on current indicators. Those indicators would be worldwide incidents that are already happening, specific industry sectors that are being targeted. So for our case, if it's a media company, broadcast company, or Canadian company that's being targeted, that would be good to know. 0 days and new exploits or malware being used, old ones that have become popular again, and hacking group campaigns, such as, what is Apt One currently up to this week? Any of that sort of stuff. Security has traditionally been reactive and not proactive to threats, but I think threat intelligence software will help narrow that gap as time goes on.
Yeah, definitely good insight. Thank you. And I would like to ask my last question. This time I like to talk to Cassis. So Cassis, we talk about a lot of things, infrastructure as a code, the CI/CD, security. How does operations remain confident without knowing the exact content of containers at times?
That's a good question, Massimo. So one of the primary things is that it's very important to come up with standards, to standardize the way in which you're doing things. And included in that, I would say both the image that the code will run on at deployment and the image that the code builds on, because sometimes those can be two separate things. In our case, developers are definitely free to experiment. They can build and deploy based on dozens of container images. So as I mentioned earlier, OpenShift provides well over 50 base container images, and they can work with those and spin them up really quickly and start experimenting. But we do restrict the source of the images to our own container image registry. So we don't want developers, in our case, going out to say Docker Hub or something like that and pulling in an image, or who knows what other source it might have come from, and then just building code on that and potentially deploying that into production. That's definitely beyond the comfort level, and you never really know what's going into those. So we restrict that completely. So all the images that they're using, we've vetted and either received through the OpenShift container platform or that we've developed ourselves. We also needed to standardize our build and deploy pipelines a little bit more. We started this process well before tools like Helm were really a thing. And so it meant that we had to write a lot of our own scripts to do it. So I alluded to this earlier, but standardizing the JSON definition objects for OpenShift and Kubernetes resources, such as deployments and such, we really had to hunker down and standardize the way that we were defining those. And we have tools that will automatically make modifications to those objects if they don't meet within our standards. On top of that, the Docker files or the definitions that I just mentioned, they're both stored in the applications repository. So they can be applied either during the build time or the deploy time. And an example of that might be if a developer makes a change to a config map within Kubernetes. That's in their code. So that gets built, and then at deploy time, it's recognized there's been a change to the config map code, and so that's applied to the Openshift environment or the Kubernetes environment, and then the deployment happens so that it can actually consume that resource. We made changes to happens obviously from the developer side. There's a bit of a risk on the operational side. I mentioned the config map a moment ago. We also had to write scripts where if that occurs and that is being promoted to production, that change is recognized and that there's something, there's a mechanism that we've written that triggers an alert to operations during that deployment, so that we have a chance to go in, look at the code and review the specific changes, as these are kind of infrastructure changes at that point, right? So that really helps us to understand what's going into the application, what's happening on the environment. And while we may not know all the specifics of everything that goes into their application within the container, we do have defined parameters that they have to follow. So I guess to sort of summarize that, we do allow for custom plans for the developers because they want to be able to experiment. But we do have some standards that they have to follow in order for us to remain confident and allow these types of activities to take place.
No, thank you. That's definitely on point. Okay, so we're at the end of this presentation, and just put a quick wrap up. So how do we do it? We talk about local libraries, solid build process, security review and code scan, custom deploys plan to accommodate the different needs. And yes, we do a multi-regions DR in failover. So that's in a very short one slide, the very top level conversation we just had. But now let me introduce my colleague Miriam. She's gonna talk to you about a few interesting things. She's a lead recruiter for CBC Digital in Toronto. So Miriam, over to you.
Thanks, Massimo. And thanks, team, for such an insightful presentation. Hi, folks. So a little bit about me. As Massimo said, I have been working at the CBC as a recruiter for 5 years now. And I lead the tech recruitment in Toronto specifically to help build and scale the digital presence at CBC. So one of the main things that I personally love about working at the CBC is how devoted everyone is to the mission of the public broadcaster. And I think this team in this presentation did a beautiful job of exemplifying that everyone is excited by the work, is eager to collaborate and to talk about it. And that makes my life a lot easier as a recruiter. So as you all know, digital is our future. That's why we're all here. So we're focused at CBC on becoming a digital first organization that provides a digital platform for our storytellers. So we believe that hiring people with different career paths and different backgrounds is fundamental. So please just feel free to visit the job boards and let me know if there's any interest. Reach out to me.
Thank you.
Sure. Thank you.
Okay, so we're gonna move to the questions. Anybody has any question? This is the time.
I believe there was one in the chat.
Yeah.
Right, and what we will do is we will unmute KB and he can ask his own question.
Okay.
So
Okay.
That's the way to go.
Hi, sorry, I didn't realize I joined in as KB. My name's Carl. So that's a fantastic presentation, and it was really good to hear your team. So awesome work and all the very best and all the new stuff that you're doing. A question was more around the traditional way organizations have been used to working through committees and change boards, which are rampant all across. So specifically, when we talk about releasing changes to production, you have these change advisory boards where groups of people come in and kind of look whether we are good to go ahead with this change into prod. So did CBC have any such committee before you really started off on your DevOps journey? And if you did, after you went ahead with this and you're at the current state of your maturity, do you still need to go through such kind of committee meetings before the change goes into prod?
Good question. I can start with them and then I'll pass to you guys. And the way it works, we don't have that structure you described. Oh yes, we do it through committees as well. So when the change of the magnitude was introduced, there's definitely an architecture group that you're overseeing the overall plan. And then we're deciding it together. There's a bunch of other groups that gets involved. It doesn't take the shape of, it doesn't go through a committee, like an official body where there's a lot of people in there, and then there's official, presentation, everybody participates, and there's a decision and a stamp of approval in the end. It's a process that we follow that basically has architecture, as engineering involved as well. We have digital people involved, developers that are directly involved in the process. And then we all discuss that sometimes together, sometimes in different stages. So it's a little bit less strict, if you will, but it still follows the best practice. And that's the way we kind of move forward in general. So maybe I'm lucky, you're a little bit more agile of a perspective. We don't have to go through a lot of silos, right? And a lot of different steps.
I would quickly add, if I may, that things have evolved there too, at a smaller level than what Massimo is describing. Just the release to the platform has changed a lot. And don't forget that we're coming from a time where releasing meant putting a couple of HTML pages and CSS onto the site, which we did through script, but went through a very traditional layer of dev, and then QA would approve, and if QA had approved, QA would send the request for it to be deployed to production, which was then done by operations, who had the power to decide when it was okay to deploy or not. We're now moving to a much more integrated DevOps environment that Cassius described, where the code is automatically built, and we are talking about building code now, about the grunting and Node and compiling and JavaScript and running a series of tests, and only once the tests are passed can the release be approved for production. And we are working towards having some releases that can be automatically approved once they have a sufficient amount of test coverage. Then we can move to a model where these can be automatically promoted to production or promoted by people who are not necessarily core operations, if that expands the...
Mm-hmm.
So
I'd just like to hop on to what Natalie is saying there. So we obviously we have some automated things to cover us off, but we also operate with many deployments to production on any given day. So not all organizations are like that. Sometimes you'll work for a long time on code changes, and you deploy those to production, and they're significant. Whereas at CBC, I probably see 20 production deployments a day. They're not all for the same application or the same part of the website, for example, but they're all components that sort of go into making it up. The idea being that we want to be able to make code updates quickly, verify them through automated processes, and then deploy them to the viewing public as quickly as possible.
Thank you. And we have another question, and I hope that we have time for this question. Sebastian, I have unmuted yourself, so if you can ask your question.
Yes, good morning, everyone, and thank you for sharing all that great information. My main question was about what are the main ingredients for you to choose a specific cloud provider? For example, in this case, it could be Azure, AWS, or any others.
I will try to answer, and Sebastian, we can talk offline on more details on that. But essentially, we go back to what I was talking about in terms of the need overriding the technology. We now at the CBC have a presence in AWS, Azure, and Google. So we thankfully are beyond the point of having to say, we are just going to go with one. We are already in 3, and the rest is dictated. What do we need to do? Do we need to have access to the internal CBC network? Do we need to have access to a specific subnet of the CBC network? Can it be handled entirely outside? Does it need to access products that already exist in, say, the Google infrastructure? The major driving factor remains right now the need over the technology.
Yeah, thank you, Natalie, for the answer. And I have the final question through which we will conclude this session. So I'm kind of, I did my part with SecOps in this meeting today. And it reflects that, when you're changing or transitioning from, where you were from a legacy perspective and being more open source, the transition would take behavioral changes, right? And behavioral changes will drive policy changes, as we have seen in today's meeting, right? So I would like to understand, Massimo, from you, that how did you handle that transition from a behavioral perspective? And you talk about, the legacy and the transition into the next generation modern application stack and infrastructure stack.
Yeah, I will have to ask you to repeat a little bit the last 2 seconds. I dropped my earphone. Sorry, I really missed the last 5 seconds of your question.
Right. So my question is that how would we drive that behavioral shift or behavioral change, which is required from going from a traditional, legacy infrastructure stack to a more modern, infrastructure as a code stack? And, what kind of behavioral changes the organization would need, and what are the steps CBC had taken?
Okay, so yeah, that's a very loaded question. It does imply that there is a cultural shift. It does imply that there is a top to bottom and bottom up communication in place. So we were lucky enough that it wasn't one single driving factor moving that forward. It happened organically. So for us, it was everybody was talking about the same topic at the same time. We got together, and then we made this happening in terms of compensation. So we were changing all together, and it was quite nice to see. However, that's not always the case. So sometimes I experienced after the first iteration of this new way to do work, that you have to find people that become your champion. So if you want to drive a change, you must identify a champion. The champion is somebody that believes in what you're doing, has the same ideas and the same psychology, and they will speak to his peers. So once you have this type of communication in place, it's not you talking to anybody else. You're literally creating the champion is going to start talking with his people in his team, and then maybe one more champion on the team, creating the cultural movement. And when the culture and the talking is in place, it requires a bit of time and adaptation. You're going to find people that are going to adopt it immediately. You get other people that are going to resist to change, because nobody likes to change, right? So people are going to be resistant to changes. You're going to push back. Everybody does naturally. It's nothing wrong with it. It's just a matter of reiterate the message. So at this stage, it's important to continue the conversation open all of the time. Make sure we hear people who have concerns. Those are the ones you're going to win over, right? So make sure you talk to them. Make sure you're very transparent and address all their concerns. This is a lengthy process. It is not for any means short. So you have to be prepared to setbacks. You have to be prepared to people who are going to be really upset, and people don't want to even talk to you. So it requires a lot of effort. It requires a lot of patience, but it does pay off in the end. It may take you a week. It may take you 6 months, or maybe over a year, sometimes even longer than that. But it's definitely a process that's worthwhile spending time on.
Thank you very much for this insightful discussion, and of course, the recommendations and suggestions. And it leads us to a point where we understand the power of community of practice of DevOps. And I truly want to thank you all, the CBC team, for coming here today and sharing the journey with us. Of course, we have so much to learn. So again, thank you very much, CBC team, for coming in and showing us how to lead that transition from, a step-by-step manner. So I really kind of appreciate your time. And lastly, the slides will be available in the meetup group. So if you are interested to, download the slides, you can visit the meetup group and take it from there.
Thank you.
Okay, thank you very much.
Thank you.